Hey 7th graders, I'm going to show you today, this is how we are going to start organizing our data. And right now I am just using the first couple of pages from your packet. Okay, I know I have a couple of pages of vocab there. I'm not going to make that required, but go ahead and fill that out if you want something extra to do. So we are going to start today by talking about frequency tables, stem and leaf plots, and line plots. So this isn't why I wanted you to really create a question that had numbers with it, because you have to get a number in order to use these different methods of organizing your data. So I'm just going to go through these examples and then you'll have a worksheet to do. And then as you start to get your data, using a frequency table, stem and leaf plot, and a line plot, those are things that I'm going to have you guys do for your project. So a lot of times you get numbers. So it says the list shows the average high temperatures for 20 cities one day in February. Make a cumulative frequency table of the data. How many cities had an average high temperature below 59 degrees? So a frequency table is, it shows their equal increments, like these all go by 20. So I know you think, oh, that's only 19, but if you include 0 and 19, that's exactly 20. And then 20 degrees is the next one, and it goes to 39. So the categories are all equal, and there's no gaps, okay? And there's no overlaps either. So when I have a number, I know exactly where I'm going to put it. 60 to 69 falls right in this category, so I'm just going to make a tick mark. And a lot of times I cross them off as I go so that I don't duplicate or forget any. 65, 51, and this is helpful because our data really isn't in order right now. 50, 50, 44, 41, oops, I should have made a tally, 38, 32, 32, 28, 20, 18. Actually, they are in order from greatest to least. 18, 12, 8, 8, 4, 2, and 2. So step 1, choose a scale that includes all of the data values. So we went all the way up and we made sure that it started at less than 2 and it went over 69. Then separate the square into equal scale into equal intervals, which we did. Then we tallied how many were in each interval. And then the cumulative frequency here, it adds up as you go down. So here is 7. Okay, cumulative, we add 5 more, so we'd get 12. And this is 1, 2, 3, 4, 5 more, so we'd get 17. And then the last one, we'd get 20. So it doesn't mean that there's 20 in this category. It means that the total was 20. And this running score means that we had 20 numbers. Well, we had 20 cities, and we ended with 20 in my cumulative frequency table there. Okay, so we're going to do the next thing with this one. Now, I didn't fill this out for you, so we've got to make that decision. If we were in class, it'd make you respond to me. So it says this is our high. It looks like these ones are not in order. So it looks like our high is 99 and our low, let's see, since they're not in order, it takes me a little bit longer. 65, 60. Looks like our low. So our low is 60 and our high is 99 or 100. So maybe we would want to start at 60. See, if you went to 100, there is technically 40 in between there, right? So we could do 4 categories of 10. So I could go 60 to 69, 70 to 79, 80 to 89, and 90 to 99, and that would get all of our numbers. Okay, so now we're going to do the frequency. 85 would go here. 84 would go here. 77 would go there. 65 would go here. 99, that last category. 90 would go in the last category. 80, 85, 95, 72, 60, 66, 94, 86, 79, 87, 68, 95, 71, 96. Last one there. Okay, so let's see here. Oh, I guess we never answered the question for the first one. It says, how many cities had an average high temperature of below 59 degrees? So here's our cutoff, right? 59. So how many were below 59? Below 59, that would be 17. Okay, and then 17, sorry, cities. I was just reading my question again. So in this question it says, let's do our cumulative frequency. We've got 4 plus 4 more gives us 8, plus 6 more gives us 14, plus 6 more gives us 20. So it says, how many students received a 79 or below? So 79 or below would include these two categories, so 8 total. Okay, so now I'm going to show you what a stem and leaf plot is. And there's technically, you can do double stem and leaf plots or single stem and leaf plots, but we're just going to focus on the single ones. So a stem and leaf plot is a way to organize data in order. And so one of the first things that we have to do is put them in order. So it says, order the data from least to greatest. Since the data values range from 12 to 40, use the 10 digits for the stems and the 1 digits for the leaves. So you'll understand this more in a second. So I'm going to take, and again, this is kind of tricky, and it's usually helpful like to have you guys in class reading this back to me so I don't lose any of them. But I'm going to cross them off as I go. So I think 12 is my lowest, so I'm going to put 12 right here. And then I think I've got 2 15s coming next. So I'm going to do 12, 15, 15. And then it looks like I've got a 17, a 17, and an 18. So 17, 17, 18, 20, 21, 22, 23, 23, and then I go to 29, and then I go to 33, 33, and then to 40. So you guys will do this with your data that you collected. So here I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it said 15 coaches, so we know that we've got the right number. Okay, so now to make a stem and leaf plot, they're really not that complicated. You basically make like a T-chart, and this is going to be your stem, and this is your leaf. Usually, the stem is based on like how many digits your number is. So because we have, they're all just a 2-digit number, this is your stem is going to be your tens digit, and the leaf is going to be your ones digit. So we do not have any single digits, so we would not put a 0, but we are going to put a 1, and then we will go 2, and we have to go up to a 4 because we've got in the teens, the 20s, the 30s, and the 40s. And then what you do is you just write, we've got a 12, so you put a 2 here. And we've got a 15, so you put a 5. Then you've got another 5. Then you've got a 17. Then you've got another 17. Then you have an 18. Then we're going to go to our 20, 21, 22, 23, 23, 29. We're going to go to our 30s, 33, 33, and then our 40, it ends right there. The only other thing you need with a stem and leaf plot is you need a key. And what this means is that you're going to show them what this means, because sometimes you have decimals, sometimes you have digits in the hundreds, that kind of thing. And so you're going to say that 1, and you could use any number from your plot here, equals 12. And what this does is this tells the person who's looking at your stem and leaf plot exactly what that means. Now, the reason we do stem and leaf plots is because rather than looking at it all like this, you can see if there are any modes, which means the most often occurring, and we'll talk about that next, probably in our next lesson. You can see where most of the numbers lie. You can see that there's not very many numbers that are in the 30s or 40s. You can see a lot of the numbers lie in the teens and the 20s. So it kind of just shows you how your data is distributed. So it's kind of helpful. Okay, let's do another one. It says the list shows the number of times a soccer player can bounce the ball on their knee. How many soccer players can bounce the ball more than 36 times? Okay, so let's take this and put them in order first. So it looks like my smallest one, the 23. Maybe I should have done this before I was on here with you guys. 27, 28, 29, 30, another 30. Looks like I go to a 33. And a 35, a 37, 38, and 40, 41, looks like there's 2 of them. 43, 43, 45, 45, looks like I jumped to 55, 55, 60, 61, and then 62 and 68. Before I finish, I double check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And it doesn't tell me how many times, so I'm going to check this list. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I made sure I didn't miss any numbers. Plus, I've got them crossed off there except for my last one. So now I'm going to make my stem and leaf plot. Same kind of like before. I have to go to 68 though, so I have to make sure that I go all the way to the 60s. So again, we're going to have a stem and our leaf, and I'll go from the 20s, 30s, 40s, 50s, and 60s. And then my leaves should get some different colors in here. 23, 27, 28, 29, 30, there's 2 of them, 33, 35, 37, 38, 40, 41, 41, 43, 45, and then 55, and then I go to 60, 60, 61, 62, 68. 1, 2, 8. Sorry about that. Okay, so anyways, you can see where most of the numbers lie. We can answer the question, how many soccer players can bounce the ball more than 36 times? Well, this allows us to look here. More than 36. Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 players. So it just allows you to organize the data and answer questions. Okay, so the next type of thing that I'm going to show you is how to do a line plot. Now, line plots are also good at showing the frequency of something happening. So how often did it happen? When you make a line plot, you need to make sure the line it basically looks like a number line. You can't skip any numbers, and you need to make sure, well, obviously if you can't skip any, you need to make sure that you have the lowest and the highest number included. So in our case, 0 is our lowest, and 8 looks like our highest. So you're just going to make a number line that goes all the way from 0 to 8. And you just make it very simple here. So 0, 1, 2, 3, 4, 5, 6, 7. Kind of cramming mine in here. 8. And then what you do, you just make an X above the number for every value that you have. So for example, I've got 0, so I'll put a line above. I've got 6, you put a line above. You've got 4, you put a line above, or X above. 6 again. 5, 8, 2. And you just do this for all of your values, because this data in the table isn't organized by the number of hours, it's just organized by the week. So to help us look at Morgan's babysitting schedule, 0, 6, 8, 5, 6, 1, 2, 4, 8, 4, 3, 3, 6, and 0. So it says, how many hours per day did Morgan babysit the most often? Well, you can easily see which one has the most. So it would be 6 hours per day was the most. And this allows you to organize it. So if you guys were giving a survey, like how many slices of pizza do 7th graders eat the most often, and you did this with your data, you could definitely see what the most common number of slices of pizza someone would eat in 7th grade. Do it one more again. Here's the pizza. How many slices of pizza did most people eat? So again, our lowest number is 0. Our highest number looks to be 6. So I'm going to make my number line, and it's going to go 0, 1, 2, 3, 4, 5, 6. And then we're just going to go ahead and make our number, or X's above the number. So a 2, a 4, a 1, a 2, a 5, a 3, a 1, a 0, a 4, a 3, a 2, 5, 3, 2. Last row here, 4, 6, 1, 4, 2, 2, and 5. So how many slices did most people eat? Most people ate 2. Okay, and so they do this with data to help get an idea of where it spreads and most common, most frequent things, and just helps you get a better image of the data more than just a table. So yes, this is nice and neat, but it doesn't really give me a good visual of what's going on. So I hope this helps you guys out, and you guys are going to do, oh, maybe I don't have a worksheet that goes with this. You guys are just going to start organizing your data. We'll do 7-2 on Monday. Okay, that's fun. So we'll do 7-2 on Monday. Oh, I suppose. Okay, sorry guys. Look right here. You can do part of 7-1. You can do the first worksheet of number 1. Okay, sorry, you have to skip a page. And then we will do 7-2 on Monday. Have a great weekend, guys. We'll talk to you later.